Next up, we've got Matthias Lubken. Oh, I knew once you told me how to pronounce it properly, I would do this wrong. Matthias Lubken. Matthias is an AI engineer and founder who specializes in AI agents for business workflow and automation. And his talk, A Piece of the Pie, Embedding OpenClaw Coding Agent in Your Product. Thank you, Matthias.
Hello, everyone. Thanks a lot for having me. Back in London, it's awesome to be here. So I don't know how you guys have experienced this year, but there was this OpenClaw thing happening in January, and a friend of mine, we organized an event in Cologne, and a friend of mine called and says, Matthias, can you do a talk? And I was like, yeah, sure, but let me find something. And I was digging through the code, and I find this awesome coding agent, which afterwards kind of took over. I feel it, at least. Who heard about pi? Yeah, exactly. That's what I'm talking about. 2 months ago, nobody would have raised their hand, including myself. But now we're all here and experiencing it. And I was digging through it, and I built a prototype with it, and that's what I'm going to talk with you about. So basically my question is, how do we design systems which are able to deliver the same magic as OpenClaw does? So this is me, this is us, Ivan and myself. We're a small agency, we're building agentic systems, we're building different tools for clients here in the UK and Germany. And come to me if you find the work interesting or want to chat about anything else. So, brief agenda. First of all, I'm going to talk a little bit, motivate this a little bit, what I mean by OpenClaw's magic. Going to briefly introduce pi, and then an example. Then I'm trying to, this is an early talk, so this looks very sophisticated. It's not, but it's basically trying to structure it a little bit. But I have a couple of primitives I want to talk about that helps us motivate this and kind of wrap our heads around it. Some primitives and some patterns, and I'm going to end the whole talk about malleable software, but more on that later. Cool. All right, so this is Peter, and this is OpenClaw. And at some point in time, he, and this was in the early days, it was basically had a chat interface, was able to send chat back and forth, but more or less accidentally, he sent a voice message to OpenClaw. And OpenClaw started thinking, right? These AI agents, they think. And then it sent a text message back. And I don't know how you guys feel, but when I see this, there is a little bit magic into this. How does this work from the outside, right? But as engineers, we're obviously looking behind the curtain, so let's have a look. So generally speaking, very roughly, right, if you do these agents, you have these general instructions, and OpenClaw has these SoulMD and all this cool things, but basically it's okay, you're a personal assistant, you do things, and here are a bunch of tools, like read, write, edit, file, bash commands. So when it, and this is a simplification, but I think you should get the idea. So initially, when it saw this file, it saw, oh my God, this is not a text file. What do I do with it, right? And it used the usual Unix commands. It inspected the file, saw it was a WAV file, then it tried to decode it with a tool that it knew about Whisper. That didn't work. And then somehow in its instructions, somewhere it's I could actually send this to OpenAI API. There's actually one command missing that it actually was searching for a key in order to send it, right? All in that, did it in a loop again and again. Again, this is oversimplification, and at some point, it got the goal completed. And again, I feel from this is awesome because I understand now what happened, but I want to reuse that magic in my tools. So very briefly, right, coding agents are these agents who have these tools that run in a loop, and that's like the general definition for an agent, having tools in a loop. But coding agents additionally have bash, right? So they have any kind of Linux, Unix tools at their disposal and some runtime. And there are all these sandboxes to run these different tools, etc. But you know, that's my go-to definition of an agent, and that's my primitive that I'm using for thinking about how I could design systems. Is like, how would I embed these into my systems? Okay, very briefly about Pi, for those who don't know. It's built by Mario Zechner out of Vienna. So very, very minimal coding agent. If you haven't used it, please give it a try. The minimalism is its feature. So the way to define Pi is what's not Pi. There's no MCP servers, there's no sub-agents, there's no permission pop-ups, there's no plan mode, there's no built-in to-dos, there's no background bash thingy. But in order to have some of these things, you can actually tell Pi to create it, right? So this is the, I don't know, Hello World example, kind of like, so you tell Pi, please create a Pi extension that asks for permission when I want to push the main branch to remote. Right, so it doesn't have permissions, it doesn't have these pop-ups, but I want now a pop-up that gets up when I'm pushing the main branch to remote. And it actually does this, right? So it creates these files. Permission gate is called dirty report guard. So it creates these TypeScripts and a markdown. Here's the summary of what it has done. And then when I push origin to main, push main to origin, I actually get this pop-up, right? I allow this command to push to remote. All of a sudden now I've changed my agent to be working exactly the way that I want to. And this is kind of like got me thinking of how would that change my software, my systems? And we're going to see this later. So in order to motivate this a little bit and make this more practical, I'm going to introduce you to an example. And this is not any type of development example. This is an application that we've built as a prototype for a client. And their request was that their quoting system takes way too long. They have this after-sales process where they sell parts, and the quote system, there's an email inquiry coming in, and then there's lots of manual processing that we want to automate. Now, this is per se not, we don't need AI to solve this, but AI makes it much simpler, and I would argue for the long run also more powerful, and we can solve more use case with it. But basically, we have an email inbox which analyzes customer requests. We check different backend systems, the CRM, etc., and then creates quotes and drafts. The architecture is very much inspired by OpenClaw, so we have some gateway where we're routing these. And then the way we've architectured this is we've basically created an agent per customer, where we have these different prompts, again, think about SoulMD, etc., but now we have it per customer. And then per case, we're creating a session. I'm going to talk a little bit what a session is, but think about one agent per customer and then one session per case. So this is a dashboard. I'm not sure if you can read this, but we have basic KPIs, we have activities. We then have an email inbox, and the way that we're doing this, we're basically replicating the inbox. At some point, it will be based in Outlook, so the user doesn't even need to leave their tool. But right now, we're replicating the inbox. And once an email comes in, it looks for a case or creates a case, and here you see that on the top right side, there's a case associated with it, and we can open it. Now, the case, again, has KPIs, and we have we can look at the clients. We have all the client information. We have different steps for this case. So everything is, kind of like the user understands of what's happening there. And then we can look into the details. And if we do this, then all of a sudden we kind of like see a little bit of what's under the hood. And again, this is an early prototype, so we'll see where this goes. But what you can start seeing is that we now have the system prompt here, right? So we're describing of what the agent is doing, of what this client, specific context, etc., and then different tool definitions. And speaking of tools, this is more like a in-depth view, so not a normal view for any type of user. But here's we can look into the session and the different steps that went through the system. And here we have different tool calls. One is the tool call of understanding the actual state of the case. So we have an ERP CRM system, a CRM system in this case, where the state is stored, and then we have an ERP system where we're looking up the parts. Both are external systems, both are APIs, and both are included as tools in this case. And then the final result is an email draft. The way we're architecturing this is that we're not sending out emails just yet. We are drafting emails so the user can actually then afterwards change the email, to whatever they're liking. The argument is that you're much faster in reviewing the email and then sending it. Cool. So that's the application, right? So the overall idea is coding agents are these awesome new tools that we're seeing in OpenClaw and other tools. Pi is one of these agents, which is embedded in OpenClaw. By the way, that's not true since like 2 weeks, so I need to change the title of my talk because they have just ripped out Pi. But that's, the talk wouldn't be so nice, the title. But anyway, so we have OpenClaw, we have Pi embedded, and now the question is, what do we do with it? And these are a couple of primitives, building blocks, right, for you to reason about. So you can take one of these and see of how you could work with this. Okay, so let's start with the agent setup. The agent setup is, not as simple, and and also this is Pi, and you can do this with other agents. So I'm not saying that it happened to be using Pi, but there are other SDKs you could do this with. But Pi is a good starting ground. So very simple, right? So you have different levels of SDKs. I'm using the coding agent SDK, so the same thing that you're running on your desktop. As a developer, you define the model, you define the different tools on how to work with the sessions and the different resources to load. Speaking of resources, I'm not usually if you start the coding agent, agents MD is loaded, and in this case I have a different of reusable agents MD that I'm storing and reusing throughout the different agents. So, we have a general describing the overall business. We have something on a little bit of task-oriented on how to query the client, and more about the client-specific, like discounts, etc., like context information. And same is true for skills, right? Right now we're not using skills as much. But the overall idea is the same. It's we are making sure that we control on how these skills are loaded into the system, and that's how you put it up. Very simple, not much, not that interesting, but I just wanted to show you on how simple it is to get started. So I think the first part architecturally to reason about is what tools do you provide to your agent, right? Again, we have these general instructions, and you can generate them. And now the question is how does this thing behave with the rest of the system, which is tools, right? So again, tools, you have this agent ID and a general description. And when you start the agent, you make these tools available. And the large language model decides when to call these tools. You start guiding them, but at the end of the day, the large language model decides, okay, I'm going to call this tool. We have 3 tools right now. Case state, which is the way of talking with the CRM, of understanding where the overall state of this case is. An ERP system where we do the lookup, and the email. Now, the part that then gets interesting when you think about how to work with these tools is where you actually start designing for the system. And the way that like when Ivan and myself were reasoning about this a couple of weeks back, the way that we phrased it is like, don't make your agent guess, right? Try to be precise about the tool definition, make it the intent revealing, make it a scope to the specific task. And by the way, you can change tools on the fly, etc., right? But that's where you start designing the system. If you think about back on OpenClaw, what is the magic of OpenClaw is that it has all these different tools at its disposal, right? File to understand the file definition, Whisper to translate an audio file. And here's the same thing, right? You need to think about, like, you don't have a predefined workflow, but instead you have these different tools that you call. So one of the first bigger design decisions that you do is defining these tools. And it's really interesting, and there's lots of written articles about this, and you need to experiment with this. But depending on the model and depending on how you do this, the self-revealing of what tools are available and how to use them is actually what the agent itself does. You all very often see this in Pi when it actually calls the tool with a -- help, for example, or inspects the error messages, etc. And there's lots of things that you can start designing around it to make your agent go do the right thing. And obviously, well, I should tell this, but obviously also don't hand out the tools the agent shouldn't use. Right? We actually have a tool called Databox where we help users with this, but this is a general pattern. It's like people are saying, okay, don't use this tool in their instructions, but they hand it over anyway. And then they are surprised that the agent deletes the database, right? Don't be surprised if you give the agent the tool, it's going to assume it's going to use it. But there are some ways you can actually help if you are not able to define the tools or you don't know anything up front. There's a couple of ways to guide the agent as well, and these are extensions. So there's different level of extensions. I'm going to talk about the eventing mechanisms in Pi, where you can basically write these extensions, and we've seen this in Pi with Pi, the coding agent in the beginning, in the example where we're listening to events. There's different types of events, different agent life cycles, session life cycles, where we can actually basically hook in and do things. The part that I'm going to talk about are the tool execution. So tool call result. This is where most of the extensions that we've built we've built. So this is the example that I showed before. We have this agent with a goal, and we're calling these tools, and now we can ingest lifecycle hooks here. So for example, before we do a tool call or after we've done a tool result. So the idea here is we cannot control that the LLM is calling it, right? That's the whole magic behind it. But when it does, we can actually ingest and filter out things or do something with the result. Here's the example from our system. We have in the draft email, when it drafts an email, we do another sanity check that the email is in the custom domain of the client. So we're kind of validating the output of a tool call and making sure that it does. So far, it always has been green, but this way we are making sure, right? So we're not relying on the instructions, but we can actually make sure that always the right domains. And you can obviously do this with other validation, all types of business logic you can put in here. And that means that the flow of what the agent does is open, right? But you can still make sure that certain systems, certain guardrails are implemented. Here are a couple of other examples for drafting emails, the state. So these are, different types of examples in this use case, and you can obviously think about your own examples. Another part where we feel that these tool calls are helpful is actually ingesting information, right? So this is all about this, context engineering thing, right? Where you make sure that the agent, that the large language model gets the right amount of information, and maybe you don't want to or you cannot do all the information up front. Because maybe it's dynamic or there's other situations. So here in this case, we can ingest certain information that we look up as we do this. Cool. So this is tools, and the last primitive I want to touch on are sessions. So this is a big part of Pi as well, and sessions is these tree structure of an event log that Mario has created, and it's actually pretty nice if you use the coding agent yourself, and you wander off and you took a detour of okay, this is going nowhere, and then it's okay, let's get rid of all it. It's really easy to go back, right? And you can do different types of trees, right? Go try one path, another path, and you still have the whole context with you, and you can navigate around it very easily. There's different types of information. So this is a JSON-L structure. So you have these JSON information with messages, model changes, different types of things. And you can ingest your own, right? Your own custom messages, which are sent to the LLM. And those which are not sent to the LLM. Custom message in this case. Sorry. Yeah, here a quick overview. But the session, so remember the way I've architected the application is that we have a case, we have an agent container per customer, and then we have sessions per case. And now that we have these sessions, right, with this audit log, and with all this information, now we can start thinking about other types of agents working on the same information. We can redo certain things or change certain things because someone has decided either manually or automatically on doing things, or we can reuse patterns. One of the things that we're exploring is that we're actually going through the session logs and we're creating a skill out of this. Right, so we're going through the session information and creating a skill afterwards, which we're going to do evals around it, etc. Right, but the point is the session log is really, really powerful, and I also think that the tree information is going to be powerful. Although to be fair, we have not explored that too much. All right, cool. So we have a couple of primitives. I hope this gives you some ideas on how you could architecture your type of applications. So let me close off with a couple of patterns or how this then builds into applications and flows. So the first one is actually the workflow, and this is the application that I've shown before, right? So the overall idea is we reuse, we give it a couple of prompts, we give it tools, we give it extensions to build these streamlined workflows. And I think this is going to be really, really powerful because the agent is going to be adaptive to whatever is coming. But that doesn't need to end there. The other one is actually the more primitive version of this. But as we have all these tools and this context information, why not give a power user a full-blown chat, right, where they can actually use the embedded coding agent in their system, right? Think about co-work now in your system. And now all of a sudden we are reusing tools, we're reusing context information in very different flows in the system, right? So again, very much power user. We actually don't have a user persona that is actually using this, so there's a little bit more thinking. But we're using this. The idea is that you can use this with existing sessions, right? So you can clear up existings, or you can actually create brand new sessions, and sessions as in cases. Now, if you keep thinking about this, about sessions, you can, and you know about the Model Context Protocol and their extension about MCP UIs and MCP apps, you can think about, okay, maybe there's something in between, right? Maybe I'm not just only chatting with it. Maybe I'm actually interacting with the session in a different way, right? So in this case here, this is a parts lookup. and we're not displaying the raw JSON anymore, but we're displaying a rich interface which we can now interact with, right? Change, in this case, change the amount of what's requested for any reason. But it's like the way that I'm thinking about it is like we have this general, this more like application that we've built. Then we have this chat. And now in the chat, we could start embedding more rich UIs, right? So it blends over one or the other. Which brings me to the final point, malleable software. And this is an article by Ink and Switch, or an essay by Ink and Switch, which I really, really like. And it talks about this idea that software systems should not be these predefined systems, but more of an ecosystem where anyone can adapt their tools to their needs with minimal friction. The example in the article, in the essay, is this specific, these kitchen tools where you have this very sophisticated slicer. I don't know if you guys still watch TV, but in Germany we had this channel where you can you get these things all day long. Or you could just use a knife, right? But knives are adaptable. You can do different things. Yes, you might need a little bit training on it, but you can do different things. And the authors of this article, they argue for software that has not these predefined flows, but rather small tools that you can reuse. The article is meanwhile adapted to the AI flows or to this AI native world, but the ideas are older. But with AI, I think, and some of the patterns that I've shown, I think we have a great deal of potential ways of doing this. And if you rethink about this, right, what can we, like, if we think about these software, these systems that we've built so far, these building blocks that we've seen, what if the software can change itself, right? Similar to Pi, right? What if a user could basically just say, like the extension that I've shown, right? The extension is just a TypeScript, right? So why isn't the user able to articulate that and say, only make sure that you don't send emails which are not in the customer domain, right? And maybe they can adapt it because of the power user, right? So that's the overall idea. Yeah, I hope you got some inspiration. And I'm not sure if we have any time for questions. Yes, we do. All right. Thank you very much.
Matthias? Do we have any questions? We've got one over here. Can we get a mic over to this lady, please? Sorry, I've had to come over here because the projector's in my eyes.
Yeah.
Thank you. So you mentioned the idea of users being able to, especially power users, sort of take control and adapt the software to their needs. Mm-hmm. How do you have any ideas on managing, I guess, the security implications of that? So obviously, certain users can be trusted to interact with the LLM and adjust the extensions, but I guess there's downstream effects from that. Yeah. Either through not understanding what they're doing or malice. And yeah, that's
very, very great question. No, thank you. So I think the way to think about it is the level of freedom always needs to stay within certain boundaries. So for example, we had these different tool calls where it's able to do different things. Not sure if you realized, but the draft email tool is exactly designed as it is. The system is not able to send emails. It's only able to send draft emails. So at the end of the day, you're in control. You are in control of what it can do, right? But here, right, again, we're drafting emails, and in this case, we're saying, like, do we want to do additional checks on that email, right? And the LLM does something, but I want to do some additional checks. And these are the kind of extensions that I'm thinking about. Like, certain power users are able to, like, they don't care. They just churn out these, or like different type of users, and others are saying starting to introduce certain guardrails or certain automations and these type of things. And that's both on the tool design level, like you need to design the tools, and then on the extensions. But the point being is that now the LLM can start calling these tools in any way, right? Now all of a sudden it's like, okay, I'm going to draft an email because there's some reason that I'm thinking about which you have not previously thought about. But with these extensions, you can put another set of guardrails around it. You're welcome.
Okay, I think we might have time for just one more. So we've got one just here.
Hi, Matthias. I have created a Gmail MCP server which does the same. What's the difference between Pi and Gmail MCP server?
Great question. First of all, great that you build your own MCP servers. That's awesome. No, it's it's exactly that, right? You have started defining the tools, and now, but the question is, what do you do with these tools, right? So you have defined your own MCP server for Gmail that only that lets you create drafts on a Saturday afternoon, whatever, right? You have like defined your special tool. Now the question is, what do you do with it, right? I'm assuming you're doing this. Where are you using it in some coding agent, in Claude Code, or some other tool? And this talk is like, first off, I think there's a future in software where systems are actually built around just defining these tools and guardrails. And there's like these power users who keep using this, right? Co-work is one of these examples. But what I'm trying to motivate, as you have defined these MCP tools, what if you start embedding them into a bigger software, right? What if you start embedding them into an email automation tool? And I would argue, please have a look at Pi or some other coding agent harness in reusing these MCP tools in order to, build that software. That's the core idea.
Okay, well, brilliant. Thank you very much, Matthias. Thanks again to Matthias. So,